A hypothesis is a specific statement about a population that can be tested. It is about a population, meaning that it is about a defined group of elements which can be people, animals, plants, etc. It should be specific, meaning it should be clear and precise so that it can be tested using statistical methods. There are 7 steps to testing a hypothesis. We will look at each step with the help of an example. This example is a hypothetical situation made simply for the purpose of this video. The average weight of Indian women is 50 kg with a standard deviation of 15. A researcher believes that the weight of Indian women has changed. How will she test her hypothesis? First, let's look at the information given. We are given the population parameter, which is the mean weight of the entire population of Indian women, that is 50 kg, represented by the Greek symbol mu. The population standard deviation is 15 and it is represented by the Greek symbol sigma. The first step in hypothesis testing is to state the research question. This means that we should specifically say what the problem is that we are trying to answer with the research. In this example, the research question is, has the mean weight of Indian women changed from the average? The second step is to state the null and alternative hypothesis. The null hypothesis, H0, is the commonly accepted fact or what is generally believed. In this example, the null hypothesis is that the mean weight of Indian women is 50 kg or mu is equal to 50 kg. This is what is believed generally. An alternative hypothesis, represented by HA or H1, is the opposite of a null hypothesis. In this example, it is that the mean weight of Indian women is not equal to 50 kg or mu is not equal to 50 kg. The third step is to specify the level of significance. Level of significance alpha is 1 minus the level of confidence. The confidence level is something that we as a researcher choose. In this example, if we assume a confidence level of 95%, which in decimal terms is 0.95, then the level of significance will be 1 minus 0.95, which is 0.05. So, at 95% confidence level of significance is 0.05. At this point, we will also determine which statistical test to use. Since the sample size is above 30 and the population standard deviation is known, we will use the z-test. If the sample size was below 30 and the population standard deviation unknown, we would have used the t-test. But in this case, we will use the z-test. This is also a two-tailed test since we want to see if there is any change in the mean weight, whether in the positive or negative direction, that is more or less than the average. If we wanted to see if there is a change in the positive direction alone, that is more than the average weight, then we would have used a one-tailed test. If you look to the right of the screen, you will see the distribution curve for the z-test. There is a hump in the center and a tail on each side. The level of significance is a red-colored area under the curve. We have chosen a level of significance of 0.05, and since this is a two-tailed test, the area will be divided between the two tails. So, the area in each tail is alpha by 2, that is 0.05 by 2, which is equal to 0.025. This area is also called the rejection region. The fourth step is to draw a random sample from the population. It is not practical to test every element in the population. So, we will pick out a few elements from the population, and this is called a sample. In this example, it is not possible to record the weight of all Indian women and then take the mean. So, we will draw a random sample of 75 women from the population. In a real-life situation, there are formulae to calculate how many women to include in the sample and determine the process of sampling. But for the purpose of this example alone, we have taken an arbitrary value of 75. So sample size n in this example is 75. The fifth step is to calculate the sample statistic. The sample statistic is the parallel of the population parameter. In this example, the population parameter mu is the mean weight of the population of Indian women. But when we say sample statistic, which is represented by x bar, we are talking about the mean weight of Indian women in the sample. So, every woman in the sample is weighed and the mean weight of the sample is calculated to be 55 kg. Thus, x bar is equal to 55 kg. From this, we will calculate the Z statistic since we are using the Z test. The formula for Z statistic is given on the screen. Z statistic is equal to sample mean x bar minus the population parameter mu divided by the population standard deviation sigma by the square root of the sample size n. By entering all these values, we will get a Z statistic of 2.89. The sixth step is to compare the Z statistic with the critical value. The critical value is obtained from the table for a two-tailed Z test using the confidence level we chose. In the table, we can see that the value of Z alpha by 2 for 95% confidence level is 1.96. It is Z alpha by 2 since it is a two-tailed test and so alpha is divided between the two tails. So, the value that divides the white region and the rejection region in the right tail is 1.96 and the value that divides the white region and the rejection region in the left tail is minus 1.96. The Z statistic which we got earlier from this formula was 2.89. 2.89 is positive, so it will be placed on the right of the curve. 2.89 is greater than the critical value of 1.96, so it will be placed to the right of the critical value. The seventh step is to interpret the results. The Z statistic, which we got from the sample data, is greater than the critical value, and so it is on the right in the rejection region. The Z statistic is in the rejection region, and so we should reject the null hypothesis, meaning that we have enough evidence to say that the null hypothesis is false. Thus, we will accept the alternative hypothesis, which is that the mean weight of Indian women is no longer 50 kg. Let us do a quick recap. A hypothesis is a specific statement about a population that can be tested. There are 7 steps in hypothesis testing. First, we state the research question. Then, we state the null and alternative hypothesis. Then, we determine the level of significance. Next, we draw a random sample from the population and compute the sample statistic. The obtained sample statistic is compared to the critical value, and finally, we interpret the results and make a decision to reject or retain the null hypothesis.